Have you ever watched a classic heist movie? Something like Ocean's 11, and you're just sitting there, completely marveling at how perfectly the whole thing comes together. I mean, the mastermind doesn't just walk up to the front door of the casino and hope for the best. No way. They assemble a highly specialized team. They've got the vault cracker. They've got the tech expert, the inside person. Every single move is meticulously calculated, timed down to the absolute second, and executed flawlessly. Well, listen up, because sitting down for your Cambridge Computer Science exam, specifically if you're taking syllabus codes like 9618, 0417, 0478, 0983, or 2210, is exactly like pulling off one of those high-stakes heists. You literally cannot just barge into that exam hall, relying on raw luck and a handful of memorized facts, expecting to walk away with the prize. It doesn't work that way. To crack the Cambridge grading vault and walk away with maximum marks, you need to assemble your own internal team of cognitive specialists. So today, we are going to build your ultimate exam strategy. We're going to decode the examiner's mind, figure out how to bypass the traps they've specifically set for you, and execute the absolute perfect answer. Welcome to the ultimate masterclass on Cambridge Computer Science exam strategy. Let's get into it.
Okay, here is the blueprint for our operation today. We're starting with a challenge, moving into the strategy reveal, going through the transformation, running a quick interactive workshop, and wrapping it all up with the final system. Let's get moving.
Section 1. The challenge. Let's look at the most misunderstood area of the vault.
To pull off this heist, we really have to look at the exact security system we are up against. According to the senior examiners themselves, Section 2.1, Networks, specifically the purpose and benefits of networking devices, is notoriously one of the most misunderstood areas across the entire computer science syllabus. Year after year, students get this wrong. To see exactly what goes wrong, let's look at two typical candidates. I bet you probably know an Alex and a Sam. First, we have Alex. Now, Alex has spent months, literally months, memorizing every single networking protocol, every cable type, every definition in the textbook. But when it comes to the exam, Alex overloads answers with raw computer science facts while providing absolutely zero analysis. It's just a superficial brain dump onto the page. Then we have Sam. Now, Sam actually really knows the material, but Sam absolutely panics under the ticking clock of the exam. Sam rushes the execution, completely missing the command word context. For example, if the question clearly says, evaluate the trade-offs of a star topology, Sam doesn't evaluate anything. Sam just writes a generic description of a star topology. Both of these approaches completely fail in the exam hall. Why? Because rote memorization and rushing are the equivalent of clumsily tripping the security lasers. It alerts the examiner that you don't actually understand the core concepts.
The principal examiner reports make an absolutely crucial distinction here, and you need to memorize this. They state, the assessment framework prioritizes analytical depth over superficial breadth. Let's unpack that because it is the absolute golden rule of Cambridge Computer Science. The examiners literally do not care if you can list 20 different networking terms if you cannot explain how those terms interact with each other. They don't want a glossary, they want logical, structured reasoning. They are desperately looking to see that you have a deeply connected conceptual understanding that you can actually transfer to entirely unfamiliar, real-world networking contexts. Depth will always beat breadth.
Section 2, the strategy reveal. It's time to talk about procedural frameworks.
So, if we know that rote memorization is out, what exactly is our master plan? Well, we have to look at how they grade you. The examiner's grading rubric is broken down into 3 distinct cognitive domains, like 3 separate dials on a safe. First, you have knowledge and understanding. This is your base layer. This is where your precise, accurate definitions live. Second, you have application. This is where practical skills come in. Things like developing programming skills, designing algorithms, or implementing actual networking solutions in a given scenario. And third, the big one, analysis. This is the critical, evaluative thinking where you are asked to consider multiple solutions and actively weigh their trade-offs. To get those top marks, your answer absolutely must hit all 3 of these domains. And to pull that off consistently, the top students use what we call the PEAL framework: point, evidence, explanation, link. It is the structural skeleton of a flawless, heist-winning answer.
When you are tackling examination questions on 2.1 networks, you need a strict, time-managed operation. You cannot just wing it. Here is the minute-by-minute breakdown. Minute 1. You deconstruct the question. Get your pen out and underline the command words. Are they asking you to identify, describe, or evaluate? Those words change everything. Minute 2. Extract relevant data. If they give you binary representations or a complex network diagram, pull out the critical constraints immediately.
Minute 3, select your analytical framework. Ask yourself, are we using Peel here? Are we doing a comparative analysis? Lock in your structure. Minute 4, execute with clear notation and present your answer with correct formal terminology. This step-by-step decomposition is exactly how you stay perfectly calm and collected while the clock ticks down. You just trust the process.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Section 3, the transformation. Let's look at the top-tier strategy in action.
Okay, it is time to put our methodology into practice. We are going to take those deeply flawed answers from Alex and Sam, and we are going to transform them live. A standard strategy, like Alex's, relies on superficial definitions. They might write something like, a switch connects devices. Guess what? That results in low marks. It's too basic. A top-tier strategy, on the other hand, actively injects causal relationships and cross-topic connections. Instead of just giving a basic definition, a top-tier answer says something like, a switch connects devices by maintaining a MAC address table, which reduces data collisions, thereby improving overall network bandwidth efficiency compared to a hub. Do you see the massive difference there? The principal examiner reports explicitly highlight that candidates who reference cross-topic connections, like linking a basic network device to data security or to overall algorithmic efficiency, achieve significantly higher marks. It shows mastery. This is the success blueprint in action.
Now, I need to share a crucial point with you. It's your ultimate safety net in the exam, the method mark strategy. Algorithmic thinking requires step-by-step decomposition, but students lose incredibly easy marks every single year simply by not showing their working. Let's say you are calculating data packet routing or working through some complex binary interpretations, and under the pressure you make a tiny silly arithmetic error at the very end. If you just wrote down the final wrong answer on the line, you get 0, nothing. But if you actually documented your procedural process, if you clearly selected the appropriate data structures on the page and actively showed your working out, you earn method marks. You get credit for the strategy, for the thinking, even if the final execution had a tiny glitch. It's like getting credit for successfully picking the lock, even if the door gets jammed at the last second. Never ever skip showing your working.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Section 4, Interactive Workshop. It's time to sharpen those evaluation skills. Theory is great, but execution is absolutely everything. Let's look at Challenge 1, this 60-second data scan. Top-scoring candidates constantly demonstrate evaluative thinking. They do this by considering multiple solutions, actively analyzing trade-offs, acknowledging limitations, and then justifying their final point with hard evidence. Imagine you're staring at a really complex networking chart on your exam paper. You have exactly 60 seconds. Your job is to extract the core trend. Don't just tell me that a fiber optic connection is faster than copper. Anyone can see that. I want you to analyze the trade-off. Yes, it's faster, but it is significantly more expensive and much harder to install. Then acknowledge the limitations based on the specific scenario context they gave you in the prompt. This level of critical evaluation, this deep thinking, is exactly what elevates an answer from a B right up to an A star.
Moving on to Challenge 2, Find the Flaw. I want you to read this sample sentence really carefully. The routing algorithm is effective because it finds the destination quickly. Okay, what evaluation metric is missing here? Think about it for a second. The fatal flaw here is that it lacks specific performance metrics. In computer science, evaluating algorithm quality strictly requires identifying time complexity and space complexity. Does the algorithm actually execute in linear time? Does it require massive amounts of memory to function? Simply saying it's quick is way too superficial for a Cambridge exam. You absolutely must use precise academic benchmarks to measure its actual effect on network performance.
All right, Challenge 3 is speed writing. When an exam question asks you to do a comparative analysis, let's say comparing a client-server network to a peer-to-peer network, you must follow strict examiner rules to get the points. First, you have to identify similarities and differences, not just one or the other. Second, you must use comparative connectives, words like whereas, conversely, or in contrast. Third, you must support each individual point with evidence. And finally, you have to draw a conclusion about their relative importance. If you just write one massive paragraph about client-server and then a totally separate paragraph about peer-to-peer without actually linking them together using those comparative connectives, you will lose the analysis marks. It is all about demonstrating how the concepts interact with each other.
Section 5. The final system. How to avoid the fatal errors.
Okay, so we've deconstructed the syllabus, we've analyzed the common mistakes, and we've practiced the execution. Now let's look at the absolute climax of the principal examiner reports. Here are the top 3 warnings. These are the fatal errors that consistently destroy otherwise perfect code and networking answers. Number 1, unchecked overflow errors. Students will perfectly perform data calculations, but completely forget to mention the physical limits of memory allocation. Number 2, ignored boundary conditions. When you are testing an algorithm, you must check the edge cases, the absolute maximum and minimum values. Leaving those out is a massive red flag. And number 3, lack of context specificity. If the exam question is specifically about a hospital's network, your answer must talk about patient data security. It can't just talk about general network traffic. Context is king. You have to adapt your knowledge to their scenario.
To make sure you never ever fall victim to those fatal errors under the immense pressure of the exam hall, here is an insider memory hack directly from the experts. Create your own mnemonic for 2.1 networks, using the first letters of key terms. Think about it. Whether it's memorizing the layers of the OSI model or remembering the exact steps for rigorous algorithmic testing, building a custom mnemonic ensures that checking for things like overflow errors, edge cases, and boundary conditions becomes an absolute automatic reflex. When the timer's ticking down and the pressure is on, a strong, funny, or weird mnemonic is your best friend in the entire world.
Look at the number on your screen. That represents the actual impact of this system. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. That's a massive leap. That is the literal difference between missing your university offer and walking into the computer science program of your dreams. The framework works, decoding the command words, applying Peel, actively managing your time, but you have to commit to applying it. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.